Hello, everyone. My name is Manny Kitagawa. I'm the Business Development Manager for the IP endpoint of AtlasIED's communication group. Today, we're going to discuss the unified communications and how IP endpoints not only provide day-to-day communications, but also is used for mass communications for all your spaces. So the first thing we want to talk about is exactly what is IPX endpoints. IP endpoints were developed about 2 decades ago as a means for companies like a Cisco, Avaya, ShoreTel, all of these unified communication companies to provide coverage and announcements for all of their spaces or all of their client spaces over and above all of the other device type communications that they have in this UC ecosystem. So let's talk a little bit about what is unified communications. So unified communications actually is a communication ecosystem. It's not manufacturer specific. And as I mentioned earlier, unified communications can be provided to a client from several, I'm going to call UC manufacturers, and that's an abbreviation for unified communications. And what that means is that when a client is having a session with one of these UC manufacturers, the topic of conversation is how do I reach all of my people in all of my spaces? And so when this discussion is had with the client, there's a number of different things that are going to be mentioned in that conversation about how a client can utilize several different types of devices in this ecosystem to provide that type of communication to their people or their spaces. Some of these devices that can be used would be smart handsets on a customer's desk. It could be desktop computers, it can be laptop devices, it could be mobile devices or tablets. Now, the luxury of this ecosystem is, again, I mentioned, it is not a device or manufacturer specific. So if your client uses a mobile phone like an Apple device or an Android device, the communication to those devices can be pushed and utilized without having concern that a client is using an Apple device or a client is using an Android device. Now, the types of communications that can be used on these devices that I mentioned can be a number of different things. It could be SMS type messages, it can be emails, it can be video conferencing, it could be many sorts of different types of communications that are needed by the client. There's a lot of collaboration partners out there. There's a lot of different companies that provide the infrastructure to support a unified communications type solution for a client. As I mentioned before, Avaya, ShoreTel, Cisco, and then there's some application manufacturers that provide applications that would help enhance the type of communication that the customer may be requiring. So to kind of get into a little bit more detail, what you're going to be looking at here is an actual ecosystem for an education K through 12 environment. This is going to be an example. So when a client is looking at, again, a unified communication ecosystem, what does that mean? So a UC manufacturer talk about communicating across a wide area network. The nice thing about that communication is it's not a proprietary type of protocol. It's actually a standard Ethernet-based protocol that can be pushed not only on a local LAN sense, but it can be pushed through an enterprise level or wide area type communication format. So it definitely leverages the need of communication across a wide area network type scenario. Now, in the image that you're looking at, what you're going to discover is there's strategically placed devices that sit on top of this existing network. There's going to be computers and there's going to be smart handsets on desks. There's going to be mobile devices and, of course, laptops and PCs. Now, the question comes into play, how do I communicate to all of my spaces? And that's a big question that comes up several times. And as you can see in the image that we have shown you here, there's question marks in these spaces. In the classroom space, yes, there is a handset in that space. But is the handset going to be loud enough? Is it going to be clear enough when an announcement is made in that space that all the occupants in that space can clearly hear any instructions or any type of notifications that are pushed? Odds are classroom that could be populated with several students or in the simultaneous type of education type process that is being produced in that space, hearing something from a handset might be challenging. So you might look at something that you would need in that classroom space to help overcome some of the classroom type noise levels that are being produced. Cafeterias is another good example. Cafeterias could be quite big. They could be quite loud. And so the question would be, would a handset or a computer or any one of these devices that we previously mentioned be enough to cover those spaces? Some of the other spaces that you see in this diagram that could be in question would be outside. There's not a lot of network type devices that can actually be placed outside for a number of reasons. Noise levels from being outside, weather conditions for being outside, or even a space like athletics. Athletics could be very challenging in the sense that there's a lot of noise, there's a lot of activity going on in an athletics field. And so you will have to be concerned about, how do I overcome the ambient noise level and maybe in a football type stadium. So these would be all questions that come into play from a client when they're discussing unified communications and how do I cover all my spaces. So by taking a look at AtlasIED and their IP endpoints, there's a simple solution. The AtlasIED IP endpoints can literally plug into an existing unified communication ecosystem, and there's several devices that are available to accommodate the space type environments, meaning devices made for outside, devices made for classroom environments, and maybe even taking a look at maybe some collaboration with some analog systems to properly cover areas like athletics, for example, where you might need some large type stadium horns to cover these type of spaces in these ecosystems. As I mentioned, there's several different SKUs or models that are available to be able to fit the right product in the right space to make sure that that product is going to overcome any type of environmental concerns, being outside as an example, weather conditions, or maybe just the size of the space, or maybe how loud the space is. So there's several models available in the portfolio that a client can select from to be able to choose the right one for that space. Now that we know the ability to attach IP endpoints into an existing unified communication ecosystem is super ideal, because again, you're going to leverage that infrastructure and you're going to level the communications on that standard Ethernet protocol. The question is, how do I maximize the communications in this UC environment? And that's actually done by collaboration partners that provide applications to increase the types of communication in these type of environments. So on the screen here, you're going to see an example of a partner called SingleWire that develops a product called Informacast that actually will increase the communications to meet the client's requirements for those type of communications. The software package can be used for day-to-day communication. So again, in a school environment, the actual software can be used for bail dismissals. It can be used for custodian type notifications. But the luxury of providing the software and using the software package in a UC ecosystem is the ability to provide other means of communication, such as critical alerts. Some of these critical alerts can be defined as maybe a need for weather type advisories. So if there is a location or a campus that wants to subscribe to any type of severe weather notifications, that can actually be achieved by the software partner that's being used in this ecosystem. If the client also wants to use the product in addition to day-to-day communication for critical alerts, maybe some things for like evacuations, or maybe some active shooter drills, or chemical spills, or any type of critical alerts that may be deemed in the client's requirement list, the software package can actually provide a means to facilitate those type of critical alerts as well. So the way the actual system will work is there's two types of triggers. There's a manual method and there's an automated method. A manual method just simply means that a person who's authorized can simply go to one of several different types of devices and activate an event using one of the smart handsets that's provided by a UC manufacturer that sits on top of a desk. logging into a web browser and using a command center. Maybe some type of alerts could be shared through some type of conferencing type communication applications like Microsoft Teams, and even down to simply using buttons. Buttons can be used in this type of environment. As an example, a button can be strategically placed and located maybe under a desk, so that in the event there is a critical situation in the campus, an authorized person can simply hit the button and activate a critical alert. The second means to trigger an event is through automation. Automation, as we talked about a little earlier, can be used as collaborating with some type of local state type of alert mechanism. So maybe subscribing to weather services. Can also handshake with third-party systems, maybe systems that are used for maybe flood type of notifications or triggers and things like that. So there's an automated process that's available as well. And simply what happens is anytime one of those triggers are actually activated, then a predefined notification can be pushed to several different type of devices. Devices primarily on-premise could be, again, smart handsets on desks, digital signage, AtlasIED IP endpoints, analog systems can be part of it, walkie-talkie radios such as Motorola radios. Several devices in the campus can be used as a means to communicate to people or spaces. The next advantage of this type of communication goes beyond the premise and goes off premise. There might be some individuals who may have a role in a type of event, and maybe the person isn't on premise. So with using a unified communication ecosystem, notifications can be pushed to devices off premise, such as mobile devices, laptop computers or tablets. As we mentioned before, or even notifications used on some type of conferencing type application like Microsoft Teams or maybe Cisco WebEx. Those type of devices make it very, very nice to communicate to all members who have a activity when there is actually an event that is activated. So IP endpoints themselves are actually very intelligent. And the nice thing about IP endpoints is they subscribe to 100% of all of the communication that's generated within a unified communication ecosystem. On the screen that you're looking at here today, what you're looking at is a model that consists of two types of methods for notifications in a given space. And those two types of notifications are audio, as well as visual. So in this particular instance, in the image, what you're taking a look at here is a product that shows time, and time is pulled from the network, so it shows time and date, and that's displayed when the product is in standby mode. Now, when the product gets an active message, that time changes to a scrolling text bar. And what that provides the occupants in that space is a couple of different types of communication needs. First need is if there's people in the spaces that might have visual or hearing disabilities, they can actually get notifications by one of the two means, either audio or visual. The product is designed with a larger amplifier and a larger speaker so that in spaces that are quite loud, then it makes the ability to hear notifications that much more attractive for occupants in those spaces. But again, anything that happens in this unified communication ecosystem actually will push to these devices just like they will any other device, such as, again, your digital signage, your handsets, intelligent handsets on the desk, and so on and so forth. Now, real use cases for the product actually become very evolved. There's a lot of clients and customers that are using both the visual and the audio side of notifications to reinforce the fact of a type of alert that's being pushed. So for example, going back to a K through 12 and type environment, K through 12 type schools usually practice drills throughout the year. And the reason for the drills is to be able to look for things that don't work, things that might have to change, any type of loopholes that could happen within a drill. Now, one of the concerns is, unfortunately, in today's world, there is a need for critical alerts, even through K through 12 type environments. So one of the things that schools have a struggle with is how do they identify the difference between a drill and a real event? And so what we're going to show you here is the horsepower of using Atlas IPX endpoints in this type of scenario to distinguish the difference between a drill and a real event. So the next thing you're going to see is you're going to see an actual video of an IP endpoint receiving a message for a drill type scenario.
Attention, attention. This is a lockdown. Please proceed to your assigned lockdown assembly area.
Now, the next video that you're going to see, same type of situation. The difference between the first video that you just previously seen and this next video that you're going to see is this next video actually is a real event, not a drill. And what you're going to see in the difference here is the visual messaging is going to be different, but the color associations with the live event is going to be different than it is with the drill, hence showing red. Red means this is a real event.
Attention, attention. This is a lockdown. Please proceed to your assigned lockdown assembly area.
This is one of several use cases that we see clients using IP endpoints to maximize the different types of communication in the school. And because you have the ability to be able to visually see and hear any type of critical alerts, it actually is a product that is really ideal for things like mass communication needs or requirements, sitting on top of your unified communication ecosystem, leveraging that communication entity so that the clients don't have to look at alternative or third-party type controllers or head-ends to facilitate the same type of critical alert needs that the client may have. Once a client has been exposed and been presented the capabilities of these types of critical alerts using the Atlas IP endpoints, there is a question that comes up quite often. That question is, how do we know and how do we confirm that all the occupants in all the spaces have actually heard the notifications, did what they were supposed to do, or in a school environment have all their students? And so by using the IP endpoints and using the unified communications ecosystem and the software application partners, there's several means to provide confirmation to authorized personnel that occupants actually have received and heard and followed the instructions that were given to them. These are plugins that provide confirmation in these type of ecosystems. And the way the plugins work is they become active notifications when an event, a critical event, is launched, and provides a client or occupants in that space the means to be able to leverage a desktop computer or leverage an IP phone to be able to signal back to an authorized person that, yes, I have all my students, yes, I heard the instructions, and yes, I did what I was told to do. So there's actually the ability to provide confirmation in these type of ecosystems. And again, just another tool making the solution that much more ideal for these type of mass communication type requirements. Some of the other things that you might find interesting with Atlas IP endpoints is the handshaking capabilities that the devices provide for integrating or working side by side with third-party systems such as access control. Fire alarm systems could be another good example. There's a lot of connectivity points on these IPX devices that allow that handshaking. There's line level audio inputs and outputs. There's contact closure interfaces. There's relays that are on board to these devices. And there's even another channel of amplification that is available if the space is large and needs to be covered in all that space. So simply by adding an analog speaker right onto this IP endpoint will provide the means to cover the larger space in question. So a lot of handshaking capabilities with that as well. So some of the devices that actually work with and have been used with IP endpoints in these type of scenarios is, as I mentioned, fire alarms, but also other type of third-party systems like burglar alarm systems or intruder systems, access control systems, Multimedia systems. And multimedia systems can be those systems, maybe in a conference room, maybe in a classroom, maybe in these areas where there's a presenter and an audience, and the presenter uses a microphone for sound reinforcement in that space. And the reason why you want to have that collaboration with those third-party systems is to provide automation to trigger the other systems, or in this particular case, a multimedia system, you want to be able to control that multimedia system so that system mutes during the broadcast. What becomes very challenging if the system's not muted is you have two audio sources in the same space. And it becomes very challenging for occupants to be able to distinguish the difference between the messaging between the two different systems, or sometimes they don't hear the entirety or partial of the message that's coming from the UC ecosystem. So by using the handshaking capabilities, the connections in the IP endpoint devices, the IP endpoints can actually mute those local systems. So the only audio source in that space is actually coming from the IP speaker during the message. Now, after the message, the devices will actually unmute the local audio system, so those systems can go back and resume their normal operation in sessions for that particular space. Some of the other types of collaboration that IP endpoints provide is integrating into other types of analog systems that are commercialized. So there are actually commercial type connections on these devices, making it that much easier to handshake with other types of audio systems that are used in that space. Some of the other markets that use the products, maybe in manufacturing or industrial type environments, handshaking with machinery and assembly lines to push notifications when there's a fault on a machine. Maybe building lighting, some of the new intelligent type LED type building lighting can be used with the devices to reinforce, again, there's a critical alert as an example. Maybe the building lighting will change red, or maybe the building lighting may flash during a critical alert. Again, used to be able to make sure occupants are aware that there is a critical alert message and can actually listen to the message when that message is pushed into that space. Now, there's all kinds of use case scenarios with IP endpoints, and it actually provides a lot of solutions where formal type designs might require several different type of third-party systems all working together to provide a complete communication solution into a space. So what that means is that in previous years, not uncommon to see a paging system and a master clock system and maybe several other systems that are used to facilitate the day-to-day communications for occupants. Because the product, again, with displays, can pull time from the network, now you have the ability to actually show time in an environment. So that removes the need to provide a additional type system like a master clock system to provide time in spaces. It's going to be the same time that all of the network devices actually sync with and pull their time from. So again, pulling time from the network. Working with collaboration partner softwares, there's a lot of features and functions that can be utilized in a unified communication ecosystem with IP endpoints. So the ability to use schedulers. So in a K through 12 type of environment, schedulers can be used for class dismissals or class starts or tardy bells, depending on the environment that the product is used in. In other markets, maybe in healthcare, schedulers can be used to make automated announcements when visiting hours are over. Maybe in manufacturing type environments, schedulers can be used to notify manufacturing that there's a shift change that's going to occur. So definitely a lot of different type of use cases for schedulers in this type of environment. Now, IP endpoints do include microphones, and what microphones provide to occupants in the space is the ability to have talkback type conversations, or otherwise known as intercom type sessions. So if there is some type of two-way communication need in that space, the session to be able to talk back hands-freely can be maximized in that space, again, by using IP endpoints in those type of scenarios. Another good use case for the IP endpoints is to provide wayfinding. In the event of a critical alert, it's important to realize that in a critical alert, you can't foresee the outcome of the event. K through 12 an example where you might do drills, or you might have designated safety areas, or instructors may pull occupants from one space and tell them to move into another space, might change just because of the type of critical alert that it's happening. So what happens is that authorized personnel can actually give instructions both visually and audibly through the IPM points, telling the occupants that they might need to gather in a different safety designated area. So another use case scenario for that as well. Now, we did talk a little bit about in the image we showed previously in line drawings about how do we handshake with larger type systems, athletics as an example. If there's a need to be able to handshake or work with an existing system like a performance venue or athletics area, AtlasIED provides IP to analog gateways to provide that type of connectivity into those analog systems. How that works is those IP to analog gateways will actually pull network audio off the network and convert them into standard balanced line level audio connectivity for any type of analog systems that are going to have to play a role in these type of critical alerts or standard communication type scenarios. So using that IP to analog gateway is a great means to handshake with analog systems, especially those that could be quite big, like a performance art venue or, again, an athletics venue. So finally, once these type of presentations are provided to a client, one of the last questions that comes up is, what about the survivability of the system? And those are very good questions. Since the IP endpoints were developed to work in a unified communication ecosystem, odds are the network has already been configured for some type of survivability or redundancy architecture. The reason why it's done that way is, for example, if there's a power outage, the ecosystem is configured and set up so that clients can still pick up a handset and dial appropriate people, even if there's a power outage. So all of those types of survivability and redundancy architectures for the network apply to the IP endpoints, again, providing survivability to not just the handsets, but now all the devices and all the areas that a client may need to communicate to. So that's part of the package as well. At the end of the day, what the ecosystem provides you with the IP endpoints is actually a proven technology that has been used for almost 2 decades now. The ability to use the system for day-to-day communication as well as critical alerts is also very ideal, having one solution or one pane of glass to be able to provide that critical type alert just as much as your day-to-day communications. The ability to handshake or provide sound reinforcement in very large areas is also very, very ideal. And again, that just eliminates middleware or any type of additional pieces of hardware for that connectivity. So again, makes it very easy to be able to provide that. And one of the most important things, or second to most important things, is the ability to communicate off-premise. Again, because you're using standard Ethernet protocols, you're able to communicate on a wide area basis and even off-premise. So again, if there are faculty members or authorized people who must engage in a critical alert and don't have or are not present in that campus, can still send and receive notifications even if they are off-premise. And finally, the survivability, active failover redundancy, just sitting on top of that survivability ecosystem applies to all the devices. Again, guaranteeing communication is not going to be disrupted for something like power outage. We did move through this presentation a little quickly, but that's okay. I think you get the general idea of the ability to exercise all of your critical needs using IP endpoints in a unified communication type of environment. We did touch on a couple of markets, but the product is actually utilized in several different type of markets, whether it's education, healthcare, manufacturing, industrial, the list goes on and on and on, where the IP endpoints and unified communication ecosystem actually is a perfect need for a client. And I want to thank you for your time. If you have any questions, please reach out to us. Thanks again.